This video will present a demonstration of the StatCrunch randomization applet for the difference in two proportions using new StatCrunch. We'll use the data from problem 3 in chapter 10 in the text. The data is shown in the first two columns here, labeled boy and VIOL for violent. It represents 29 boys and 15 girls on probation in Ventura County, California. Of the 29 boys, 10 were convicted of violent crimes. Of the 15 girls, 11 were convicted of violent crimes. We want to determine if there's a significant difference in the proportion of boys and girls who commit violent crimes. If you scroll down in the file, you can see that toward the bottom of the boy column, it actually lists the data for the girls. So we'll use the first two columns, boy and VIOL, to construct the applet. So the first thing we want to do is click on StatCrunch, Applets, Resampling, Randomization Test for two proportions. And then you'll see this screen. So what I want to do is scroll down, and I'll use summary data. So sample 1 is the data for boys. Success in this case is committing a violent crime. So there were 10 successes out of 29 boys. Sample 2, there were 11 successes out of a total of 15 girls. And we'll click compute. And then StatCrunch sets up the applet. And if you click on data over on the left side, you can see the data for the original sample. So the proportion of boys who committed violent crimes was 0.345, proportion of girls 0.733. So the difference was 0.345 minus 0.733, which is negative 0.389, or I think actually negative 0.3885. So in StatCrunch, in the applet menu, you'll see that it sets up these two regions, negative 0.3885 or below, positive 0.3885 or above. And as we construct the applet and do the randomizations, it will plot the number and the proportion of randomizations that fall into each of these two areas. And that will be important, as we'll see later. Okay, so to start it, we'll click on one time, and you can see StatCrunch select the first sample. The idea is if there's no difference in the proportion of violent crimes for boys and girls, then any one of the data points could represent either a boy or a girl. Okay, so now I have one randomization, and it's plotted over here in the bar chart. If I click on the number 1, it'll show me the actual data for that particular sample. So the proportion of boys in that sample who committed violent crimes is 0.517, girls 0.4, so the difference 0.117. Okay, so now we want to construct more randomizations, so we'll start by clicking on 5 times, and you can see the bar chart start to build. So now we have a total of 6, and none of these was the difference in sample proportions less than negative 0.3885 or greater than positive 0.3885. So in other words, it wasn't more extreme than what was in the original sample. Okay, so now we want to build a sizable number of resamples, so we'll click on 1,000 times 3 times. Okay, and now we have 3,006 resamples. Of those, 52 in 52 of those, the difference between the proportion of boys and the proportion of girls committing violent crimes was less than negative 0.3885. In 27, it was greater than positive 0.3885. for a total of 79, or about 2.6%. Now I can look at those. If I go over here and click on one of the samples in red, you can see this particular one. So the proportion of boys in this one that committed violent crimes was 0.621. Proportion of girls 0.2, so the difference 0.421, which falls into the area of 0.3885 or above. Now if I go down here and click on one of the red bars, I can see all the samples in which fall into that particular category. Okay, so the red bars, the sum of the proportions in the red bars represent what we'll call the p-value in a hypothesis test. And what it represents is the probability of selecting samples in which this difference in sample proportions was greater than what it was in our original data if the proportion of boys and the proportion of girls who commit violent crimes is equal, or in other words, if the null hypothesis is true. So what we want to do with that is determine whether the results that we got in our sample are unusual or not. So this says that about 2.6% of the time in these 3,006 resamples, I got an outcome that's more extreme than what I had in the original data. And we'll talk about this when we get into hypothesis testing and using the p-value to determine the outcome of a hypothesis test. But what we'll want to determine is whether something that happens 2.6% of the time is unusual or not.